friends, students, welcome back once again. So in my channel, as you know, we discuss more about the projects, different type of projects for all grades, that is micro to major projects. So today I have come up with the idea of main or major project, that is a higher level project. So the name of the project, AgriGuard Smart Pest Repeller and Crop Health Monitoring System. Okay, so it's a low cost solution for pest management, crop health management or monitoring, and the communication is LoRa, so it's going to the long range communication, and also you have remote monitoring. It protects the crops from pests while monitoring soil health. It uses the ESP32 microcontroller with LoRa communication for long range data transmission, making it ideal for remote farmlands without internet connectivity. The system consists of two main function modules here. Two main modules are there that we are discussing how it works. So module function key components, what are the key components and their functions? Pest repeller detect pest movement and activates ultrasonic sound speaker as well as normal sound speaker. There are two speakers, one is ultrasonic and one is sound. Deterrent PR sensor, it is detected by PR sensors also and ultrasonic sensor also. So you have two sensors, that is ultrasonic and PR sensor, and two sound modules, that is ultrasonic sound and normal sound. So crop health monitor measures soil nutrients. The second point is moisture and temperature. For precision farming, NPK sensor is used. NPK sensor, that is soil moisture, temperature. Apart from that, you will monitor other parameters of the with the help of NPK sensor also. This last point is data from both modules is transmitted via LoRa to a central gateway for monitoring and analysis. So hardware components, what we have used, I will just give you a little idea about it. That is, there are two parts here, that is transmitter and receiver part, right? So where we have connected all sensor nodes, that is our transmitter part. So we have used one ESP32 board. So LoRa communication, LoRa module, we have used RA02, 433 megahertz. You can use any of the module, that is SX1276 also, that works on 868 megahertz or 915 megahertz. So PR sensor we have used here. This is normal PR sensor we have used. Ultrasonic sensor we have used here. PR sensor also for detecting the flies and all that is pest control. Then you have used SR04, that is also for use for them. Then speaker we have used 25 to 40 kilohertz, that is ultrasonic sound for making ultrasonic sound. And we have also used a buzzer, that is 5-volt buzzer for making the normal sound. Soil moisture sensor, any captive sensor can use. We have used a captive sensor, a normal this thing. NPK sensor RS485 Modbus module is there. That is for measuring nitrogen, phosphorus, and potassium in the soil. So this NPK sensor I was not having it, so I just could not use this. And but without this, but you can use it. DST22 temperature and humidity sensor is used. So this is your transmitter part. Now we'll go to the receiver part. Okay. So here I have given the components. You can see on the right hand side, which is for receiver as well as for transmitter both. Okay. So first let's discuss about the receiver part. That is ESP32 again, LoRa module, and one OLED display. Okay. Only here the components are very less. That is LoRa module, ESP32, and 1.3 inches OLED display for getting the information. So all the sensors are in the transmitter side. Okay. Right. Okay. So this you can see this the speaker, that is ultrasonic speaker. This is a buzzer, ultrasonic sensor. This is soil NPK sensor, right? This is with the 3 leads and all. And this is normal sensor for moisturizer and temperature. This is my LoRa module, and this is my PR sensor. And this is the display. Okay. So next is circuit connection. So transmitter and receiver side, when you connect to ESP32, so the connections are same. That is NSS is connected to GPR5, SCK to 18, MISO-MOSI to 2319, reset pin and DI0 pin. That is, these are the common pins which will be from both the sides. DST is connected to GPR4, DST22, that is for temperature and humidity. Ultrasonic is connected to pin number, trigger is connected to 12, equals 27. Buzzer is connected to 15. Okay. And ultrasonic speaker, that is the output for making a sound, that is connected to pin number 16. Soil moisture, again, it is analog we have used, so it will be connected to ADC, that is pin number 34. And the NPK sensor, if you are using it, then there are two ports to it, A and B, that is data plus and data minus, which is connected to GPIO 17 and 16 segments. So these are the connection which have been there. And receiver side, receiver gateway, you have only OLED connection. As I told you, LoRa module, same as transmitter, and OLED connection is our GPIO 21 and 23, that is SPM, SCL. The library which are required for the codes are, you have to do it in Arduino IDE. That is, first you have to go to Arduino IDE, sketch, include library, manage libraries, then LoRa by Sandeep Mistry. This is the one library. Then DST sensor library by Adafruit. Adafruit SSD 1306 or LED display. And for NPK, we have used Modbus master library. So these are the libraries which you have to use it. Alert condition, yeah, you can alter in your codes, which I will be sharing with you. The parameters are normal range, warning range, and danger range. So suppose soil moisture, it is 40 to 70. Warning range will be 30 to 80, and danger range will be 20 to 90. Whereas temperature, normal temperature is 15 to 35, more than 40 and more than 45 degrees for a danger range. Okay, that is the thing. And for NPK sensor, nitrogen 20 to 40 and 15 to 50 for warning, and above 60 is danger, or 10 to 60 is danger, you can say. Phosphorus also same way, 5 to 30, the 10 to 20 is the normal range. Potassium, 15 to 20 is the normal range. These are the different ranges you have to add or you can change in your codes. All right, so these are the parameters. Let's go to our lab, and I will just try to show you the small system. And I will, of course, deal with the whole thing can be through cloud. We have used the ThinkSpeak cloud, and you can see this on the ThinkSpeak, this thing also. We can do some advanced customization, that is multiple sensor nodes can be used here. We can also attach it to solar power optimization. We can also use an SMS alert using Pillow, that is the application. And also we can save the data to the SD card also. So these are the additional things you can do, or you can add up this thing, right? So 4 main points you have to understand: pest management, crop health monitoring, long range communication, and remote monitoring. These are the 4 things where we are getting from the output. Okay.
All right, friends. So we are in our lab now. First, I will show you the transmitter part. Okay, the LoRa and the transmitter part. So we have used here. You can see ESP32. This is my microcontroller where I'm putting my screwdriver. This is LoRa module for 33 megahertz. Okay. So I've used 2 boards over here. That is this board and this board. On this board, I have buzzer which is connected to the given pin, and this is soil moisture. Okay, so now these are the terminal for the soil moisture, and PIR sensor. This is my PIR sensor for pest, whether these thing are some flies and everything are coming or not. So buzzer, LoRa, and this is ultrasonic sensor. Okay, this is my ultrasonic sensor, and my temperature and humidity, and the supply has been given from 5-volt regulator. This is 5-volt regulator because more number of sensors. Okay, one more thing, there is one more speaker. This is not a speaker exactly. For flying away the pest, we have used a ultrasonic speaker, okay, which is connected through the transistor, then it is connected to the speaker. Okay, one more sensor which I have not connected, but I will like to show it to you. That is for your NPK sensor, that is for your potassium and other nitrogen, phosphorus, potassium content in your soil for that testing purpose. So that only is to be added, but this is sent. This is the transmitter which will transmit through the antenna, which is here. The antenna is here. I've kept it here, antenna. This is the antenna, and it will be receiver side. So I will just show you the receiver side also. Okay, so this is my receiver side. So Agri Guard, it is coming, and node AG01, that is the node number. We can keep number of nodes. Soil, temperature, NPK levels, that is I told you 3. What are those 3? That is phosphorus, nitrogen, and potassium level. Since I have not connected, it is all showing 1. Okay, and preset, yes, it is there, and RSI it's minus, but that is a signal level it is showing. So these are the my receiver side. Again, I have used ESP32 LoRa module and the antenna. Okay, so receiver side only on a single breadboard I have made this connection. Please watch it again. Okay, these are the kind of this thing, and now what we will do is we will go to our ThinkSpeak cloud, and there we will check, because this is IoT project. Through we have the send the agri data. from the transmitter side, which is this side, transmitter side. This is exactly the transmitter side. It will come to the receiver side. Okay, and the data will be going to ThingSpeak Cloud also. So I will
ThingSpeak Cloud. So my project name, I have just given a title, small title, that is Smart Pest Repeller and Crop Health Monitoring. So I made these fields, that is Smart Pest Repeller and Crop Health Monitoring. One, soil moisture is there. Second is temperature. Third is humidity. Fourth is nitrogen and phosphorus. Okay, and that another one I have kept is as pet detection. Okay, because pet detection means there is a sensor, again the sensor what we have, a PIR sensor we have used for that purpose. So these are the parameters which will be coming. As you can see, 1740, this is the time when the parameters was this. Okay, so it was detected at this particular time. The same thing, it will be changing and it will be shown on the graph, that is ThingSpeak Cloud. Okay, now so as you can see here, these are the libraries. This Modbus master libraries for your NPK sensor for potassium, nitrogen, and that sensor. That is to know the content of this. So I'm not connected it, as you know, but even then I just wanted to show you, you can connect that particular sensor, a bit costly sensor, but you will get it in the market. Anyhow, rest of the things, that is PIR sensor, Eco is connected to pin number 13, Eco and trigger pin of SC05, that is ultrasonic sensor is connected. Buzzer pin, speaker, that is speaker of ultrasonic speaker, we call it as. Soil moisture is pin number 34 and DHT pin is pin number 4. So this is NPK sensor, pin number 17 and 16. And DHT22, it is given to a different pin, that is, you can find it out. Okay, so what the frequency we have used for 33 megahertz, and we have given string node to AG01. Okay, this is my node. Okay, now you come down here because as soon as when the pest are control, as you have must have seen, it will be changing the values here. Okay, the values are changed here, and you will find that it is coming. It will be updating after few seconds, or whenever there is some changes in soil or this thing, or pests are seen, or some flies are seen. This will get automatically updated. Okay, some movement will be there, some this thing will be there inside. Automatically, the buzzer will come up, and you will get the information on the ThingSpeak Cloud as well as this. So I will share this program with you. And the receiver side of the module, that is AgriGuard Smart Pest Repeller and Crop Health Monitoring System. This thing. So these finally are the libraries here, and we have connected same again. This is to be taken care of. That is this number, node number, as well as what is the frequency. SSID password, and this is important. That is your ThingSpeak ID, that is right ID, and all this is related to sending the signal to the your ThingSpeak, and the display which will be shown just now. We have seen the display that will be coming on this. Okay, so this is you can take this project as a major project, and it is connected and on. So I'll show you another window with this, and you can see with another window also. Okay, so this is one window, this is one window. Okay, so one is transmitter and one is receiver. Okay, so I hope you like this project. If you like it, please comment on this, and if you want more help, of course I will be sharing both the transmitter and this thing to you. New project idea that is related to agriculture and using LoRa technology. But thanks anyway. Thanks for watching. See you next time.